All right, today let's take a look at some free response questions from actual previous AP tests. So these ones that we're going to look at just deal with implicit differentiation. And then after we go through some of these, we'll look at the scoring rubrics and see how these are actually scored on the AP test. Okay, so this first one that we're going to take a look at was on the 2005 test. This one actually had 4 parts. There was a part D, but we don't know how to do part D yet, so we're just going to look at parts A, B, and C. All right, so let's just go through piece by piece here. Okay, the first part just says, consider this curve, y squared equals 2 plus xy, and we want to show that dy dx equals this. Right, so on problems like this, they tell you what the derivative is supposed to be. Okay, part A is just give me the work that shows this is the derivative. Now the reason that they do that is a lot of the rest of the question you'll need this, so they don't want to just screw you right off the bat. Right, if you don't know how to do part A, then you can't do the rest of the question. So they give you what the derivative is. So even if you don't know how to do this differentiation, you can still do the rest of the question. All right, so let's go ahead and take a look at finding this derivative. Right? Hopefully we can implicitly differentiate this. So the derivative of y squared would be 2y dy dx equals, now the derivative of 2 is 0, plus xy. We'll have to use product rule here. So the derivative of xy, derivative of the first, is 1 times the second plus the first times the derivative of the second. So now I want to get my dy dx's on one side and everything else on the other. So I'll go ahead and subtract this x dy dx over to this side. So we'll end up with 2y dy dx minus x dy dx equals y. Now I can factor out my dy dx and get dy dx times 2y minus x equals y. Divide both sides by 2y minus x, and we get dy dx equals y over 2y minus x. And that's exactly what we wanted to show. Right? So we have completed part A of this question. Right? That's everything we needed to do for part A. Now part B says find all points on the curve where the line tangent to the curve has slope of 1/2. What does that mean? Right? Well, slope of 1/2 means that dy dx equals 1/2, right? So what I want to do is take my derivative, y over 2y minus x, and set that equal to 1/2. Right? So I'm going to say 1/2 equals y over 2y minus x, and I just want to go ahead and solve this then. So if I multiply, or if I cross multiply here, that's going to be the easiest way to do this. I get 2y minus x times 1 equals 2 times y. All right. So if I now just do a little bit of algebra, I can subtract 2y from both sides and end up with negative x equals 0, or just x equals 0. Well, the question says find all points, and it even, shows us they want the whole coordinate point, x, y. So I also need the y coordinate that would go along with this. Well, once I get my x coordinate, how do I find the y coordinate? Well, I need to plug that back into the original equation to get the y-coordinate. So if we go back, look at our original equation, that was y squared equals 2 plus xy. Right, so we've got y squared equals 2 plus xy, and I'm plugging 0 in for x. So when I do that, y squared equals 2 plus 0 times y. Well, obviously then this just becomes 0, and I get y squared equals 2. Take the square root of both sides, and I get y equals plus or minus the square root of 2. So the answer then, we end up with 2 coordinate points. Right? We get the point 0, negative square root of 2, and we get the point 0, positive square root of 2. Right? So those are my 2 coordinate points where the line tangent to the curve has a slope of 1/2. Right? Let's take a look at part C then. Right? So in part C it says show there are no points on the curve where the line tangent to the curve is horizontal. Okay, well, I mean, this tangent to the curve is horizontal. Whenever we've got a horizontal tangent, that means the slope is equal to 0, right? So, well, let's just start by setting dy dx equal to 0 and see what happens, right? I mean, that's a lot of times we just have to start playing with what is going to happen, right? I mean, right off the bat, I have no idea how to prove that there aren't any points, but what I do know is it's saying dy dx is equal to 0. So again, what was our derivative? Y over 2y minus x. So I'm going to say 0 equals y over 2y minus x. Okay, well, here I can multiply both sides by 2y minus x, so I just get y equals 0. Okay, so just like the last problem then, okay, if I have half of a coordinate, I want to find the x-coordinate, so let's plug 0 into my original function, right? And that was y squared equals 2 plus xy. So y squared equals 2 plus xy, and I'm plugging 0 in for y, so we get 0 squared equals 2 plus x times 0, and we get then 0 equals 2. This is a false statement, right? 0 does not equal 2. Therefore, right, we can say, and we would want to write something like this out, okay? Just having this work might be enough, but I mean, we want to be sure. Okay, so when in doubt, write out an explanation. Okay, I mean we should do that most of the time. So we can say, just therefore. Well, actually, let's write out a little bit more than what I was going to say. Let's say since y equals 0 when dy dx equals 0, there are no coordinate points where the tangent is horizontal. Okay, just something like that. All right, so we've completed this entire free response question. Right now, like I said, I did chop off part D, okay, but what I want to do now is take a look at the scoring rubric, okay, how this is actually scored. Okay, this is the document that is given to the graders of the AP test, okay, that tells them how to score your free response. So if we remember part A, okay, part A was just show that this is the derivative, okay, and they have y primes in here instead of dy dx's, but it means the same thing. So if we look over here, okay, this is the correct work, and then this is the point distribution. You get 1 point just for implicitly differentiating. Okay, what that means is just tacking on a dy dx. Right? They give you a point just for tacking on a dy dx every time you take the derivative of a y. Then you get another point for correctly solving for dy dx. So part A was worth 2 points. One for just tacking on dy dx's, and another for correctly solving for dy dx. Okay? I mean, that's an easy 2 points. In part B then, right, if you remember, let's look back at part B. The very first thing we recognized was the slope is 1/2. That means dy dx equals 1/2. So that was the very first thing we did. We set the derivative equal to 1/2. You get a point just for doing that. For setting the derivative equal to 1/2, that's a point. Okay? Then correctly solving after that is worth another point. Okay, so from there we found that x had to be 0. Then when we plugged that into the original equation, we got y equals plus or minus the square root of 2. Okay, so again, just the setup was worth a point, and then the answer was worth another point. In part C, right, again, you get a point just for determining that y was equal to 0. Right? Then another point for the explanation. Okay, the curve has no horizontal tangents since this was true, right? We said 0 was equal to 2, and that's obviously not the case. So here, the parts that we completed were 6 points. Remember, I've mentioned before that every free response question on the AP test is worth a total of 9 points. So on this one, the part D that we aren't going to look at was worth 3 more points. Okay? But every free response question is worth a total of 9 points, and you can get, even if you don't know how to do the entire question, okay, you can pick up points here and there. I mean, like for this one, just for tacking on dy dx's, you got a point. Just for setting the derivative equal to 1/2, you got a point. All right, so even if you're not sure how to complete the problem, try something every single time. Okay, you get points for your work. Okay, a lot of points for your work. Right? I mean, here, half the points were for the answers, half the points were for the work. All right. So what I want you to do now is try the second free response question that you have. Okay, take 10-15 minutes here, pause the video, and try it. Okay, there aren't going to be any questions that pop up in the video. All right, I just want you to pause the video and try this. Okay, if you want, you can go piece by piece, or you can try part A, then watch the video for part A, try part B, watch the video for part B, or you can try the whole thing and then watch my explanation. Okay, so take a second, pause the video right now, and try that. Okay, let's take a look at this one. Okay, this one was from the 2000 AP test. Okay, and again, part A, same thing as part A in the last one, right? Just here's our original equation, show that dy dx equals this, all right? So, all right, let's try this one. All right? I'm going to have to use product rule on both of these pieces here, okay? X times y squared and x cubed times y. So product rule on this first piece, derivative of the first is 1 times the second plus the first times the derivative of the second, so that would be 2y dy dx. Then product rule here, all right? So this minus sign, we can do one of two things, right? We can either think about this as negative x cubed as my f, or I can just subtract this whole thing. I like to think about this negative x cubed as being my f. I think it's easier to keep signs straight, and then the y is my g. So the first thing is derivative of f, so negative 3x squared times y, then plus the first, which is negative x cubed times the derivative of the second, dy dx, equals the derivative of 6 is 0. So now I just want to collect my dy dx's on one side, get everything else on the other. So I'm going to subtract this y squared and add this 3x squared y to the other side. So we will end up with 2xy dy dx minus x cubed dy dx equals 3x squared y minus y squared. Okay, and I wrote it like that because that's how it appears here. I want to make what I'm doing look exactly like what they're showing me. Okay, even though negative y squared plus 3x squared y would technically be the same thing, I want to make it look identical to what they have. Okay, so now my next step would be to factor out my dy dx. Dy dx times 2xy minus x cubed equals 3x squared y minus y squared, and then divide by 2xy minus x cubed. And we get dy dx equals 3x squared y minus y squared over 2xy minus x cubed. And I have exactly what they have. All right, so I have completed part A. All right, oops. Come on. There we go. All right, part B then was a little different than the part B on the last one. Okay, it says find all points on the curve whose x-coordinate is 1. Okay, well, if I'm talking about on the curve, I'm talking about the original equation. So what this first part is saying is plug 1 in for x into the original function and see what happens. Okay, so let's go back here. My original function was xy squared minus x cubed y equals 6. So it's saying plug 1 in for x. So if I plug 1 in, I'll just end up with y squared minus y equals 6, right? Because both of these would be 1. So y squared minus y equals 6. Now I want to solve this. Okay, so how do I solve a quadratic? Well, I first want to get everything on one side equal to 0, so I'll subtract this 6 over, and this actually factors pretty nicely, right? Two numbers that multiply to negative 6 that add to negative 1 would be negative 3 and positive 2. So we would get y plus 2 times y minus 3 equals 0. And when I solve both of those, I would get y equals negative 2 and y equals positive 3. So what we just found, okay, find all points, so that there are two coordinate points. Okay, the two coordinate points whose x-coordinate is 1 are 1, negative 2, and 1, 3. Okay, well now it says write an equation for the tangent line at each of these points. Okay, well, to write the equation for a tangent line, I need two things, right? I need a coordinate point, and I also need the slope. Well, I have my two coordinate points. Now I just need to find the slope. So I'm going to take these two coordinate points and plug them into my slope formula here. All right. So first, dy dx of 1, negative 2 equals, I have to go back here, so 3 x squared y, so 3 times 1 squared times negative 2 minus y squared, so minus negative 2 squared over 2xy minus x cubed. So 2 times 1 times negative 2 minus x cubed, so 1 cubed. Right, that was right, yeah. So I just want to evaluate this now. So we get 3 times 1 times negative 2 is negative 6. Minus, so negative 2 squared is 4, so minus 4 over 2 times negative 2 is negative 4 minus 1, so negative 10 over negative 5 equals 2. Right, so what I have now, okay, for my first tangent line, remember I'm going to have to write 2 of them here. I've got the slope at the point 1, negative 2 is 2. So this tangent line will be y minus negative 2, so y plus 2 equals my slope of 2 times x minus 1. Okay, that's my first tangent line. Now I want to do the same thing for the point 1, 3. So dy dx of 1, 3 is going to be 3 times x squared times y minus y squared all over 2 times x times y minus x cubed. So we end up with 3 times 3 is 9 minus 9 over 6 minus 1. So that's just 0. Right? So now we have the point 1, 3 and a slope of 0. So I could write out this whole thing. I could say y minus 3 equals 0 times x minus 1. Okay, this just ends up being y equals 3. So my two tangent lines are here and here. All right. So this was a longer part, okay? And we'll see that part B here ends up being 4 points, I believe. Right? So that's why it was a little bit longer. Okay, so now let's take a look at, come on. There we go. So the last part, find the x-coordinate of each point on the curve where the tangent line is vertical. Tangent line is vertical, okay, means that the slope is undefined, right? So dy dx is undefined. Well, my dy dx was, I gotta go back here, 3x squared y minus y squared over 2xy minus x cubed. 2xy minus x cubed. I want to make this undefined. Well, to do that, I need to think about where the denominator is equal to 0. Right? That's what's going to make something undefined. So all I'm going to do is set that denominator equal to 0. Right? That's what will make dy dx undefined, and hence the tangent line vertical. So how do we solve something like this? Okay, well, I want to try to factor it. I can take an x out of both of these terms. So if I take an x out, I'm left with 2y minus x squared equals 0. Right? So if I set both of these factors equal to 0, I just get x equals 0, and 2y minus x squared equals 0. So here, I can add that x squared over, get 2y equals x squared, multiply by a half or divide by 2, right? It is 1/2 x squared. So what does this tell me? Okay, well, these are two possible answers, right? Two possible clues to tell me the x coordinate. Okay, well, this first one, at x equals 0, let's see what happens there. Okay, see if that actually works. So if I go back to my original function, I've got, let me write this down here, x times y squared minus x cubed y equals 6. Okay, minus x cubed y equals 6. If I plug 0 in for x, well, that would make this whole thing 0. That would make this whole thing 0, and I would end up with 0 equals 6. Right? That's not a true statement. Okay, so if I plug 0 back into this function, that's not a real answer. Okay, that means this doesn't actually tell me anything. So let's take a look at this piece. Okay, if I plug 1/2 x squared in place of my y's, well, I've got x times 1/2 x squared squared minus x cubed times 1/2 x squared equals 6. So let's simplify here. Okay, I've got 1/2 squared would be 1/4, right? X squared squared would be x to the 4th, times another x would be x to the 5th. So I've got 1/4 x to the 5th out of this term here. Now here, I've got 1/2 times x squared times x cubed. That would again be x to the 5th equals 6. Now these are like terms, right? 1/4 minus 1/2. This would be the same as 2/4, right? So 1/4 minus 2/4 would be negative 1/4 x to the 5th equals 6. Well, my goal is to solve for x, so I want to get rid of this negative 1/4. To do that, I can multiply both sides by negative 4 and get x to the 5th equals negative 24. Now, since this is an odd root, I can take, or an odd power, I can take that root of both sides. I can take the 5th root and end up with x equals the 5th root of negative 24. Okay, and that's my answer. Okay, there was only one solution here. There's only one x coordinate because this one did not actually work. Okay, and that's a tricky part here. Okay, you have to recognize that this one doesn't work. Okay, it appears that we got two answers, but really we only got one. Okay, because when I plug this in, I get 0 equals 6, which is not a true statement. Okay, so last thing, let's take a look at what the scoring rubric looks like for this problem. All right. So the first part, okay, part A was just showing that dy dx equals this, just like the last problem. 1 point just for tacking on the dy dx's, another point for solving for dy dx correctly. All right. Part B then is a little bit longer. All right. That's where, okay, we first plugged in 1, right, and then solved for y. So just plugging in 1 and getting y squared minus y equals 6, that was a point. Then correctly solving for y, right? So that's just a quadratic, right? Correctly solving there and getting y equals 3 and y equals negative 2, that was another point, right? Then finding our slopes and writing the correct tangent lines, those were another point each, right? So part B here was worth 4 points. Now, part C then, right, recognizing that we needed to set the denominator of our slope equal to 0, that very first step was worth a point. Okay, sets denominator of dy dx equal to 0. Right? The next thing we had to do was solve that. Right? We got x equals 0 or y equals 1/2 x squared. So the next point was a little bit further down, right? Taking this and substituting it all back into our equation, and then correctly solving for x. X equals the 5th root of -24. Okay, so the very last part on this was pretty tricky. Okay, this was worth a couple of points, but I mean, we should have been able to get the majority of the points on this question, and we did actually do the full 9 points here. Part A was 2 points, B was 4 points, and C was another 3 points. Okay, so this is what free response questions on the AP test look like. Okay, and if we can get 5, 6, 7 points on every free response question, you're going to pass the AP test easily. All right. So even if you didn't get these last couple of points, right? Even if we only got 6 or 7 points on this, that's still a win. Right? That's still very, very good. All right. So I want you guys to go ahead then and take a look at these next couple of free response questions and a couple questions out of the book that we're going to do in class. Right?